Welcome and thank you for tuning in. Please subscribe to the channel so that you receive all the videos that I upload. Please like the video and share. Now today I will be going over a couple of questions to demonstrate how to use sequential structures, C++ arithmetic operators, and how to manipulate your numeric output. Now if you don't understand these three concepts that I have mentioned, there is a video that I've done explaining all these three and more in terms of how to use the C++ function library as well, how to do typecasting and all those concepts. Now, if you want to look at the video, I will post the link down on the description below. Please go check it out. So there are 5 questions I'll be going over. So let us begin. The first one reads, the total number of students in a class are 50 and 35 are boys. If 74% of the total students get a distinction, out of which 19 are boys, write a program to calculate the total number of girls that got a distinction. Now, let us head over to VS Code. That's what I'll be using to write the solutions. Let me create a file. I'll just say it's unit B, exercise 1.cpp. Take include IOStream for my output. I will just declare the namespace so that I don't have to write the std every time I use the cout. Then I obviously need a main to run a C++ program. At the end of the main, you need to return 0. And let us begin. Now to break down the problem a little bit, I will go back to the questions. So we know that the total number of students in a class, there is 50 of them, and then 35 of those are boys. If 74 of the total students get a distinction, out of which 19 are boys. Now, if you read the second part, all we need from the first statement is that total number of students. And then once we get the 74, so the 74% of the total number of students, we can then subtract 19, and then the remaining will be the number of girls that got a distinction. So let us head over to our VS Code. So now the first thing that you can do is to take down your constants as well. So this will be the total number of the students. So we know that is 50, and it's an integer, of course, because there will never be 5,2 students in a class. It will always be a whole number, so that's why I'm assigning that to an integer. The second part now is to get the 74% of the total students, which are the ones that got a distinction. Now I'm just going to say that will be distinction students, which that is going to be 74%. Now 74% is obviously 74 divided by 100, which is going to be 0.74 times the number of total students, which is 50. Now this will give you the total number of students that got a distinction. Now we know that the number of boys that got distinctions, it's 19. So the total number of students that got a distinction, if we subtract 19, the remaining number of students will be the girls, because the question says write a program to calculate the total number of girls that got a distinction. Now let me quickly show you the total number of students that got a distinction. Say that the run. So as you can see that out of the 50 students, 37% of the students got a distinction. Now, obviously, what we need to do now is to subtract 19, and the remaining students will be girls. Now, to go, I'll just say int girls is equals to the total number of students that got a distinction minus the number of boys that got a distinction, which is 19. And then this should be number of girls that got a distinction. Number of girls that got a distinction is equals to, and then girls. That will be the solution. So here, what we used as an arithmetic operator is that multiplication. Now we should see the answer now. 37 minus 19. The number of girls that got a distinction is 18. So that would be how you would write the solution to that. Moving on to the second question. The second question reads, write a program that takes in a 4-digit number, add 1 to the number, and then divide by 3 and multiply by 0.25. Use shortcut arithmetic operators only and display the answer rounded off to 3 decimal places. Now there's a couple of steps here. The first part is to take in a 4-digit number, add 1 to it, divide by 3, multiply by 0.25. But the restriction here is that we should only use shortcut arithmetic operators. Now let us head over to VS Code. Let me create a file for this, which will be unit B, exercise 2.cpp. Now let me copy over structure here so that I don't have to rewrite everything. Now the first thing that you need to notice here is our final answer. That the final answer must be rounded off to 3 decimal places, which means all of our operations or arithmetic operations, they must be done with the type double so that we can have decimal answers throughout each step so that we don't lose our decimal points. Because if you assign anything to an int, it will only take the whole number and leave out all the numbers after the comma. So you want to go double number, so this will be the 4-digit number that we will take from the user. Now there's no need to assign your variables on declaration because your C++ compiler will assign default variables. In this case, for a double, it will assign that 0. There's no need to assign it, but I just like to assign my variables, and then I'm just going to display a message here. Make sure that people do enter a 4-digit number, and then I'm going to take that number on the same line, and then cin number. That's the first step done. The second step is to add 1 to the number. Now there are a couple of ways to add 1. So the normal way would be to say number plus 1. So that what the compiler will do is will take your number, it will add 1 to the number, then it will assign it to number, right? Then there is the shortcut version, which you don't need the number, you just add the plus sign. So this is the same as the one that I've just written, which is number plus 1. So what this thing does is that it takes number, it adds it to 1, then it assigns the answer to number. Same thing as this one. The other shortcut arithmetic operation that you can use is called the increment. So you can just add those plus plus sign. It will increment this variable by 1. Right? This is called a post increment. It comes after the variable. And then if you wanna use another way, it's called the pre-increment. So if it's just on the same line, there's no other numbers and arithmetic operators on the same line. Those two should do the same thing, but I will just use this shortcut version for consistency. And I will just make sure that everything is a decimal. I'll add that to 1.0. Then I will divide by 3. So it's the same thing. Divide your number, that's the division sign, equals to 3. I will just make that 3 a decimal as well. Even if you make the 3 a whole number, a double is more significant than an int. So an operation between a double and an int will give you a double, especially since you are also assigning it to a double. There's this thing called casting, which I will show you on one of the questions in this exercise. But I'll just make it a double for simplicity's sake. And the last one is to multiply by 0.25. Now that will be number multiplied by 0.25. Then assign it back to number. Then see out our answer, which is number. And then I can just append a nice string so that we can see that this is now our answer. Let us run that. So it will prompt us to put in the 4-digit number, and then there is our answer. Let's put in another number. There is our answer. It's a whole number here. There's a decimal here. Let's put in the last one. I'm hoping that it has more than 3 decimal points after. That is 3 as well, but that's fine. That's fine. So it means that the C++ compiler will give you 6 digits max by default. Now that is fine. Let us then do this now. So the question says we should make sure that we display the answer in 3 decimal places. Now from what it looks like is that is the default state of the compiler, that it will give you 6 digits. That's 1, 2, 3, 4, 5, 6, which means if you have 3 digits before the comma, it will max the 3 after the comma to 3 as well. Now I'm not sure how to make your answer be at least 7 digits so that you can see that what it will do, it will take 4 digits before the comma, then will take 2, because the maximum width of your numeric output is 6. Now that is fine. Let us first test out something here. Let us first complete the question, how to round off to 3 decimal places. Now, as I've explained, that this thing looks at the total digits. It does not only look at the digits after the comma. So what I will do is to say this is the rounded off answer now. Rounded off answer is equals to, and then I'm just going to add my end line there quickly. Now, how to manipulate your numeric input, or in terms of setting your precision or your digits after the comma, you use what is called set precision. Now, for you to use the function set precision, you need to include the header file iomanip. So this is the header file that is used or contains functions to manipulate your numeric outputs. So before you output the actual number that you want to round off, you must first set precision, and then your number or answer. Now, for this question now, it is a bit tricky to set the precision for this one because you don't know what the whole number, which is the number before the comma, will always be. This might change, but from what I'm looking at here, the number before the comma will always be a 3-digit number, right? Now, that might be true because that might not be true because what I'm thinking right now is that if you enter a, I'm running that, okay, let me just put in 6 here. Then if you enter 1000, you see there, you see, now that's 2 digits. Now look at how different now this is, that if it's a 2-digit number, now the output, forget about this one, as I've said that the default for your C++ compiler is 6 digits, right? Look at that. It's a 6-digit number. Instead of 3 digits now after the comma, it is 4 digits after the comma. Why is that? Because set precision, or the width of your numeric output, the setting does not look at the numbers or the digits before the comma and after the comma. It looks at the numbers as a whole. Now, if I wanted, this is a perfect test. If I wanted to then now round off my answer to 3 decimal places, I will have to set precision to 5 so that it goes 1, 2, 3, 4, 5, which will be 3 digits after the comma. That's how the set precision works. Now let us use 1000 as our answer. Let us say that's 5. Now if you run that, you would see that if you put in 1000, now this is the answer that is not rounded off. This is the answer that is rounded off. As you can see, it's 3 digits after the comma, 5 digits in total. So that's how your set precision works. Now it's difficult to set precision for a number in which you don't know how many digits will be the whole number, which is the number before the comma. However, depending on the number, so if I was doing if statements and all that, I would first check the digits. I would check the total digits of number and then set the precision accordingly. That's the only solution that would work, a dynamic solution for this problem here. Because if the answer is 6 digits, then the set precision must be 6, so that you take all those 3 digits after the comma. If it's a whole number, of course, we don't want to output the zeros. Then if it's a 6-digit number, set precision must be 6. If it's a 5-digit number, set precision must not be 6, it must be 5, so that you always have 3 digits after the comma. But to show what the question wanted you to understand is that shortcut, arithmetic, and then how to set your decimal places after the comma, and how the set precision actually works. It looks at the whole digits, but not only the digits after the comma. So I hope you understand that. Moving on to the next question. So it's question 3. It says that the length and breadth of a rectangle are 5 and 7 respectively. So there are no units here, so it's just numbers. Then write a program to calculate the length of the diagonals of a rectangle. Now it would be worth looking at this a little bit. So now let me draw a rectangle. Now the length, set the length is 5. Then the breadth is 7. Now they're saying calculate the length of the diagonals. Sorry about that. Now this is the one that we want, the diagonal. Now this will obviously, if you look at it, this is a right angled triangle if you look at only the half side. So this is almost like an hypotenuse of this rectangle right here. So you just need to take that out as a shape. And then you have your rectangles here. So that's your 7. And then this is your 5. And increase the thickness there. It's already increased. Now to get the distance of that diagonal, it's obviously the distance formula, which is a square root of 7 squared plus 5 squared. Now I'm saying it's the distance formula because of we will take the other sides. So if this was an x, y coordinates, we'll take the other coordinates needed here as 0. So it's just the Pythagoras theorem derived from the distance formula. Now you know that this will be your length s squared plus your breadth s squared. So this is the formula that you need to use to calculate your diameter. Now let us go write the program to this. This is the third exercise. I'm going to add unit B, exercise 3.cpp. I'm going to copy over that structure again, then remove that. Now for us to use the square root and the power and everything, sine, cos, we need the header 5 for those functions, which is called the math.h library. So this is where you will get all those functions that you need. Now I'm going to quickly declare my length as 5 and my breadth as 7. Then I'm going to write the formula to my diagonal. Now the diagonals of a rectangle are equal. Once you calculate one, you have gotten the other one. So we'll just do one, then both are equal. Then let us go. It goes, we need the square root first. And how to write a square root in C++, that is the square root. So you have your square root, and the next part will be the length squared. Now how you do that is to use the power function first. So it takes in two parameters. The first parameter is your base, which in this case is length. The second parameter is your exponent, which is 2. Then you add, as the formula suggests here. Then you have the second one, which is breadth. The base is breadth, and then the exponent is 2. And that is how you have your distance or your Pythagoras formula. Now all you need to do is to then see out the answer, which is D and 9. Now let us run. As you run that, there you have it. Your answer is 8. That is the length of your diagonal. Now I want to highlight something quickly here that you should be aware of. That if you look at these, the square root, there is a possibility or a chance that because of the square root, the answer that you get on D, it might be a decimal. Now, if you assign decimal as an int, now you might lose all the decimal points. Depending on how precise or how the answer is needed, you should always make this here a double, so that now you have that option. If they want a decimal number, you can just cast it to an int and take the whole number. If they want a decimal number, then you have the option of setting your precision or outputting the total or the whole number. Now, to do that, you just change everything to double, double, double. Then now this whole operation for arithmetic will happen as a double. Now, if you run that for the same answer, you can see now that because of we were doing this in integer type, it was discarding all that. But now, because of we are doing it in double, it's showing everything. Now, be careful of those little things in terms of types. Now, as I've talked about in the previous question or exercise, you can see that even here, it's rounding off after decimal to 6, to 5, I mean. It's not because of it's rounding off to 6 per se, but because of the total width of a digit or your numeric output is set to 6. So as you can see that if you count 8 plus 5 here, it's 6. So depending on how you want to manipulate your decimal places after the comma, you can use set precision. But just notice that and understand the type that you use. That is very important to your answer and operations. Moving on to the fourth question. The fourth question reads, write a program that displays the fraction 5/9 as a whole number and round it off to 5 decimal places. All right. Now this is typecasting. Now we'll quickly create another 5. Now this one, that is exercise 4.cpp. Enter. I will copy the structure once more. Paste. So take that fraction. Now for the first one, which is the whole number, I can simply just go on ahead and say int number, or maybe let's say whole number is equals to 5/9, right? Or even better, we can say int input. No, it's fine. Let me continue the way I wanted to explain it. Now, this is the whole number. Output is equals to, just append a little string there, whole number is equals to, and line on your whole number here. So if you run that, it will give you a whole number. Because why? This here is an integer divided by an integer. So the answer here will be an integer. It will ignore all the decimal digits after the comma. It will only take the whole number. So if you look at that, 5 divided by 9, it's 0 point all the other digits. So the answer here should be 0. So if you run your program, there is the whole number, which is 0. Let me run that once more. There's your whole number. Then if you wanted to have a decimal number now, which is the one that you should round off to 5 decimal places, go on ahead and say this is the decimal number. Now for the same 5 divided by 9, So as I have explained that this is an integer, the compiler says this is an integer, this is an integer. The IDE also, if you hover above this, it will show you that pop-up that this 5 is an integer, this 9 is an integer. Now the operation here will be an integer. So for us to make sure that this is a double, because also it will take that integer and assign it to an integer. Even if this was a double, assigning it to an integer will only take the whole number. So the first thing you need to do, make that a double, right? Then you must typecast this, force it to be a double. So there are two ways of doing that, right? You can either write this as double numbers, which in this case, you are kind of changing the question, because the question says take this number and make it a double, but it is fine. This is how it will give you a double. Let us do this here. See out decimal number, answer, decimal number, and line. Save that, run, and then as you can see, that's the whole number. This is the double number, right? So if I remove those, even though you are assigning this to a double, it will still give you 0. So I've highlighted double. Let us run that once more. So it's still giving you 0. Why? Because before it assigns to the variable decimal number, this is an integer, this is an integer. Now this operation is an integer, so it will take the whole number, which is 0. Once that whole 5 over 9 is done, the answer is 0. By the time it comes and assign it to the double, this is 0. It will assign 0 here. Now, if you don't want to change the question by appending point 0, you can then use the second part, or the second option of typecasting, which is telling the compiler that make this a double. So you do that by round brackets and then put in the type that you want these digits to be converted to. That's type converting, typecasting, same thing. Now, if you run this now, this will be treated as a double. This will be a double, so that will be a double divided by a double. The answer here will be a double assigned to a double. Then you will see that now you have your double answer, which is 0.5556. Now we go to the second part now, which said this double must be rounded off to 5 decimal places. Let me clear this. So if you look at our current answer, that we have 2, 4, 6 digits after the comma. Now you will notice that this number, if we set precision, because this looks like there will be a lot of numbers after the comma, but I just want to show you that that's because that's the maximum default. Now for us to manipulate our numeric output, we need our IO manip data file, and then let me just say 10 so that you can see that it will now output a 10-digit number. There is 10, but we don't want 10 and we don't want 6, we want 5, as the question suggests here. Now the good thing about this now output is that we are sure and we always know that we only have one digit before the comma, so we want to set 5 after the comma, so meaning in total it has to be always a 6-digit number, which means now you can just put your 6 there. The answer will be a 6-digit number, meaning you will only have 5 digits after the comma. Now, as we've seen on the previous questions, that the 0 is an insignificant number. right? The set precision doesn't consider zeros when it outputs unless it comes before a significant number after the comma, or it comes after a significant number before the comma, meaning it comes after 1, 2, 3, 4, 5 going to 9. So now if it's a 0 here, you need to then only count the numbers after the comma, which means now you will be considering 5 because 0 is not counted because there is no significant number, meaning 1 to 9 coming before the 0. Now this is the correct solution. So if you count those, that will be 3 and 2, that's 5 after the comma.
Now moving on to the last and final question. That's number 5. The question reads, a company is responsible for packing oranges in boxes. So write a program to determine how many boxes will be needed to pack these oranges. Now the oranges are packed in layers. Each layer takes 25 oranges. 6 layers can fit into a box. Enter the number of oranges and determine the number of layers and boxes needed to pack the oranges. Only full boxes are counted. Also, display the number of oranges left over that could not be packed. The company has 200 boxes max and 1,200 layers. Display the message if the boxes and layers will not be enough. Okay, now we need to unpack that problem statement a little bit because it is too long. Now, we understand that this company packs oranges into boxes. So the program needs us to determine how many boxes will be needed to pack oranges. So meaning given the number of oranges, how many boxes will be needed. And then the oranges are packed in layers. Now this is where the formulas start coming out now. They're saying each layer takes about 25 oranges. So from that statement, we can get a formula to calculate the number of layers needed given oranges. So obviously, if you look at that, you need to divide the oranges by 25 to get you layers. But let's just move over to the whiteboard and write out the formulas clearly. Now I'm going to show you a very simple way of deriving formulas given ratios. Now it tells us that one layer will give you or stores 25 oranges. Stores 25 oranges. Now, if you wanted to get layers given oranges, right? Or you were given oranges and then you wanted layers. Now let's just say you were given 200 or let's say you had the 1.2 layers. Let's just see how many oranges can be stored max in those. So this is how you derive formulas from ratios. So you can have that as an unknown given that you know the number of oranges. But for now, let me just show you how many oranges. If you want to get the max oranges that can be stored into layers, so you cross multiply, then that will be x times layers, or layer is equals to 1.2 what? Switch off that shit. Okay. So that will be 1.2 times 25 oranges. So don't forget these are layers, right? 25 oranges. Now for us to get our total number of oranges, divide by that one layer, divide by layer, and then this layer will obviously take out the 1200 layer, and then that layer takes out that layer, and then all you're left with is x is equals to layers, the number of layers times 25, which will give you the max oranges that you can store, which that when I calculate that, it's going to be 1200 times 25, which is 80,000 oranges max that can be stored into 1.2 layers, which that's 200 boxes. Now, the opposite now will happen, that if you want to get your layers, you just obviously divide by 25 on both sides. So it will say layers is equals to, given the number of oranges, which is your x, divided by 25, that will give you the number of layers that can store these oranges. So that's how you derive these formulas. And then if we go on and look at the other part, it says that 6 layers can fit into a box. So for us to get boxes, the number of boxes, it will be boxes is equals to layers divided by 6, because that's how many layers that can go into a box. So your total number of layers divided by 6 will give you the number of boxes that will be required to store those layers. And obviously we know that only full boxes are considered. So meaning that for us to count a box, it must have 6 layers inside, and all those layers must be full, meaning then it must have 25 times 25 apples, of course, in each layer. So that's 25 times 6. So inside there must be a maximum of 150 apples. That's what we are counting. This is 1 with those conditions met. 6 layers inside, 150 apples in total. That's 25 times 6. So that's the formula for getting boxes. Then it continues to say, now write a program to determine the boxes. Then there are your boxes. We've got the boxes. Then it says that enter the number of oranges and determine the number of layers and boxes needed. So it's saying that question twice, meaning it needs those boxes. Now we've figured out how to get our layers and boxes given the number of apples. And then they are saying only full boxes are considered for sure. Only display the number of oranges left over that could not be packed. The company has 200 boxes and 1200 layers. Display the message if the boxes will not be enough. Now, the leftovers, right? This is how you'd want to determine the leftovers. So we are saying now, given the x apples, and then let's say we are storing those. Let's say, for a quick example, let's say we had x as 100 153, right? Apples. Now, given our understanding of what a full one box is, we know that we'll store 150 apples, 6 layers in one box. Now, if we subtract 150 from there, we are left with 3. Now, meaning we have one box that has all the 6 layers, and then it has 150 apples inside. So that's a full box. Now, we can't store these because it will only be 3. That will be a single layer that's not even full. And the question says we are only considering full boxes, which means there must be 150 apples inside 6 layers in one box. Now that is what is the leftover. The leftover. So for us to calculate the leftover, we obviously need the mod because that's what gives um, the remainder. Leftover, same as remainder. So the mod will give us a remainder, and how you use mod is that you divide by whatever you need out of that number, which out of those numbers, the batches that we need when we are given a total number of apples that's supposed to be 30,000. If you are given your total number of apples, we need to take out batches of 150. So which is why leftovers, it will be the total number of apples to the total number of apples divided by, and it's not even divide, it's mod. Let me fix that quickly. So that is going to be, pardon me a little bit, this becomes invisible at times. Now that has to be x, that has to be x mod 150. Now that will give you the leftover. Whatever answer comes out there, that is the leftovers after we have stored everything. So we have figured out how to get the leftovers. Then the last part now, it says that also display a message if the boxes and layers will not be enough. Now that's also pretty simple because these are the maximum number of apples that can be stored in all those 200 boxes inside 1200 layers. Now all you need to do to see if the boxes will be enough or not, right? If you want to see that our packaging will be enough or not, all you need to do is to take your apples and then subtract 30,000, right? Now, if the answer here is positive, meaning that x is greater than 30, so it means the space is not enough. Or we can just simply swap these around so that the positive is a positive, because now look at that. If this is positive, then it means it's not enough. So it's positive, negative. Now, let me just swap that around so that it can be a bit simpler to think about. Now you will understand what I'm saying in a moment. Let me just wrap this off. So this is what I'm saying. Let me just move this 30,000. Okay. Now, if you subtract x from here, which is your total number of apples, Now, if your answer is positive, it means that 30,000 is greater than your number of apples, which means the packaging we have, it is enough. So if it's equals to 0, it means it's the perfect 30,000. We can store everything fully and finish all the boxes, finish all the layers. However, if it's negative, right, if it's less than 0, it means now we have a number of apples that is more than 30,000, which 30,000 is the maximum number of apples that we can store. So it means that we don't have enough packaging now for your number of apples. Now that is how you would calculate everything. So from what I have on my screen now, we have all the formulas we need to calculate everything. Layers, boxes, we can get our leftovers, and then we can determine whether our packaging will be enough or not for the given number of apples. Now we have broken down the problem statement. Let us go back then and read the first requirement. 5.1 says draw an IPO chart and flow diagram for the problem statement. Okay, that is quite a hassle to do, but it's not hard. So let me turn on the shape adjuster, enhancing shape. Yeah. So now an IPO chart or chart, however you pronounce it, is a 3-column table. So I'm just hoping that this fixes this shape here to be a proper square. Give it time. There you go. Then we'll have 3 columns. So the first one for that I is called an input. And then that shouldn't be a big column because the input is the number of apples. Then here for P, you have your process, which is what we will be using for our calculations and processing our input data. Pardon my line there. And then the output should not be this big as well. You can just make it a bit thin because all that is we are just displaying. There is no much explanation on the output. So this there will be the output for the O. And then I'll try to write a straight line. Not too bad. Okay, the output there is just the total apples. You have your input. Now on the process part, you can write it in sentences if you want, but it's a lot shorter if you write it in point form and using formulas. Now the first thing that we need here, as we have calculated on top the side, is that we need layers, boxes, leftovers, and then to determine whether our packaging will be enough or not. So the first process that we'll be going through. So an IPO chart describes your algorithm, which is the step-by-step process into solving this problem. Now we have layers, which will be your apples, divided by 25. That's the first answer. Second one will be your boxes, which is your total number of layers that will be storing those apples, divided by 6. And then you have, I think it's leftovers, the apples that could not fit into a box. So if the leftover is less than 150, then you will have your apples, mod by 150. That will give you a leftover. And then the last but not least is to check now. So this will be, I'll just call this a check, to check if our packaging is enough or not. So we are going to say the maximum number that we can store, which is 30,000, minus the apples, right? Then if the check is less than 0, which means it's negative, we know that we need to then output a message that's saying packaging not enough, or will not be enough. I see what's making this slow now. That shape adjuster there. Let's go. Will not be enough. Now that's one of the outputs that we will need. The other output that we need is to also display the leftovers and also determine the layers boxes. So everything. So here we'll be outputting our layers, we'll be outputting our boxes. All these are obviously what is going to be used to store the input number of apples. Now we have leftovers, we'll determine those. Then that is your IPO diagram. Your input is total apples. This is our process to determining your layers, boxes, leftovers, and the check to check if the number of apples that we have received, are we going to be able to store them or not. Then this is what we need to display in the end of the program. Now let us confirm everything. Now we need to determine, so we take in oranges, determine layers, boxes, and then we also determine leftovers. Last but not least, we determine if the packaging is enough or not. Then that is your IPO diagram. The next part of the question says write the flow diagram. Once you have the IPO chart, I don't think in a single question you can be asked to do both the IPO diagram and the flow chart, because they are doing the same thing. So they are outlining your algorithm, but in just, so it's two different structural processes, but we will do that just to show a flow chart for those who maybe do not understand it. So it's the same thing, it's just an input and output process. However, this one is inside shapes instead of a table. So you should have your start, then we'll have our input. So now I will need that shape adjuster to adjust my shapes, and then I will have something like a rhombus here. Then I will have my apples, which is the input. Then I will have my layers, which is the apples, divided by 25. So this one goes inside a rectangle. Then I will have my boxes, which is your layers, divided by 6. That will be a rectangle as well. And then I will have my leftovers, which is your apples, mod 150. That will be inside a rectangle as well. Then the next process would be for me to calculate my check, which is 30,000, 30,000 minus X, or apples, I mean, sorry. So now once I have my check, I need to then determine whether the answer, right, is less than or greater than 0 or equals to 0, but the one that we need, because if it's less than, or if it's greater or equals to 0, it means that we have enough packaging, and then when there is enough packaging, we are not needed to do anything. We are only required to output the message if it's less than 0. So that's just a condition that I will check. So if the check, I'll just say C for check, is less than 0, meaning it's negative, meaning the apples are greater than 30,000. If this is yes, then I know that I must display a message. So it not enough, let me just say not enough packaging. That's your message. Then we will stop the program here. Program is done. Second to stop. However, if this is no, meaning that your answer is positive or equals to 0, then it means we have enough packaging. So when there's enough packaging, we don't need to do anything. Stop. Then that is how your flowchart will look like. Taking apples, get layers, get boxes, get leftovers if they are leftovers, check if we have enough packaging or not. By taking the max we can store, subtract apples from there. If it's negative, it means that we have more apples than we can store. If we have, if we don't have, if the check is positive, then it means that we have leftovers. If it's 0, it means there are no leftovers, and we have the perfect packaging for storing that 30,000 apples. Now, let us move on to the next question, which is write the program now planned in 6.1. I think that was supposed to be 5.1. Now, the planning that we did here was our algorithm. Now we go and write that out. I'll create a new file for that as well. Unit B, exercise 5. I'll do the same thing here and take the structure, paste here, and close those. Right, and remove that. Let's see. Now the first things that you can take out of this program are your constants, like the 200 boxes and the 1002 layers, but I don't think those will be used anywhere. So besides using those, that 1.2 and your 25 to calculate the maximum layers, these constants here, you don't have to write them in the code. Now the first thing that I will do is just to declare my int max apples. I'll just call this max apples. These are the max apples I can store. Max apples, I'm going to say that's 30,000. All right. Then I will go on and say, now the program says enter the number of apples, so it means we need to take in a user input, cout, enter apples. Then I'm just going to take that on the same line as well, cin. I'm just going to call those apples. You obviously need to declare that. And then apples will never be a fraction or a comma. It will always be whole numbers. Now I'm going to take that as an int. Apples is equals to 0. Now, of course, if you do not assign that, compiler will assign it to 0, but I just like to assign my variables declaration. Then I have my input now. Next step says determine the number of layers. I know that layers is equals to, now I'm going to already assign this to an integer so that I avoid having those decimal, because I am not going to consider decimal. I only consider full boxes. Now this is why I'm writing this as integer, so that whenever we have a decimal, we just take the whole number. We take the full boxes only. We don't care about the remaining apples or half-packed boxes. Then layers is going to be, obviously we have our formulas there. It's apples divided by 25. Now that's apples divided by 25. Then you have your layers. The next part says they need boxes. So if we go to our flowchart or IPO chart, there are your boxes. Boxes is given by equals to layers divided by 6. And then the next part will be to calculate the leftovers if there are leftovers. Now let's go int leftovers is equals to apples mod 150. Now the last but not least is the check now, right? Get our check, int check is equals to the max apples minus the apples. And then this is going to be an if statement to check, of course. If check, as I've said, that I'll only check the condition that allows me to display the message. If that is negative, meaning it's less than 0, then I want to simply display that packaging is not enough. Not enough package. And this here, you can write whatever you want on the message, because it was not given what to write. It just said output a message, right? Display a message if the boxes and layers will not be enough. Now you can write whatever you want there. Now that is everything now, right? And then on top of this check, what I will do is okay, even if it's at the bottom, because if the packaging is enough, then it will just output this only. But if it's not enough, it will tell you at the top that we don't have enough package, and then it will output everything that it has calculated. So the first thing that was required there, it's layers. Now so just the layers equals to, simple and straightforward, give your layers and line, then cout the boxes are equals to boxes and line, then cout if they are leftovers, no, and leftovers equals to leftovers and line. Now that should be the whole solution there. I don't know why this is complaining here. So exercise 2. Oh, it's the extension here. So let me rename that. CPP sharp. Now, let us run the code now. A simple one, because I don't have test data here, but I know that given 80,000 apples, that should be the easiest one that we test with, because that should give you 200 boxes, 1 point. That should give you 200 boxes, 1002 layers. Let me switch off this. 1.2 layers, and then no leftovers. Then the packaging is enough, so no message. Then I have one that I was playing with, but I think for 153, the one that we talked about when we were deriving the remainder formula, it should give you 1 box, 6 layers, and then it should give you 3 leftovers, and then no message, right? And then I'm going to take in 25,000. I know that I think that was 166 boxes. Not sure about the layers. And then the remainder should be 100. And then there'll be no message as well here. Then we'll just take a big number so that we can see the message. Now let us head over and run our program. First one, 30,000 apples. And then there, 1,002 layers, 200 boxes, 0 leftovers, no message. Perfect packaging, right? Run that again. Let's take in our 153. So we know exactly here that it should be 1 box, 6 layers, 3 leftovers. As you can see, 1 box, 6 layers, 3 leftovers. Now I'm going to put in that 25,000 I was talking about. What I know about this 25 is that the leftovers is 100. Now you can check that as well. Now there, that's my interest there. Boxes, I know it's 166, and it means there are 1,000 layers. Then obviously the packaging is enough. Now let us put in 40,000 or whatever number is greater than 30,000, and then there, right? We would need 1,742 layers, which we don't have. We'll need 290 boxes. There'll be 62 leftovers, and yet there is no message. Now it means there is something wrong, right? So let us look at that. What went wrong? Because we don't have the message. We should get, oh, so I was expecting the message after everything. There is the message, the first part. So the packaging is not enough. I hope you understand the solution. This is how I would approach it. I hope you understand now sequential structures. That's the IPO chart. That's the sequential, that's the flow chart, I mean. And then the last one is the pseudocode, which you can look it up online. Thank you for watching. I hope you enjoyed. Keep practicing.